Right, let's have a look at number 3. Sketch the area enclosed by the curves y minus 4 plus x is equal to 0 and xy is equal to 3. Show the points of intersection. Obviously, we will have to calculate those points of intersection. So, sketch the area enclosed by the curves y minus 4 plus x is equal to 0. Let's have a look at what type of graph is this. So we got y minus 4 plus x equal to 0. What graph is this? You can see y to the power 1, x to the power 1. This is a straight line. Right, here, so we know that this is a straight line. And then xy is equal to 3. You should be familiar if x is being multiplied by y and it's equal to a number, then this is hyperbola. Right, so this is a hyperbola. So now let's sketch these graphs. So y minus 4 plus x is equal to 0. So what do I have here? Y minus 4 plus x is equal to 0. So you have a straight line. If I want to find the y-intercept, let x equal to 0. So if I let x equal to 0, y minus 4 plus 0 is equal to 0. Solve for y. So then y is equal to 4. If I want to find the x-interception, then I'm going to let y equal to 0. So if I go back here, I'll go 0 minus 4 plus x is equal to 0. Solve for x. So then x is equal to 4 also. Right, so the x-intercept is 4, y-intercept is also 4. So that's 0, 1, 2, 3, 4. Let's go 1, 2, 3, 4. So we know this point here is 4, 0, and this point here is 0, 4. Right, so that's your x and y intercept. Take your ruler and draw your straight line. Right, then we got the graph x times y is equal to 3. So now we got x, y equal to 3. Right, so now you know that if x multiplied by y is equal to k, this has to be a number. Right, so now there's two possibilities. We know that if k is positive, and then we could have another possibility when k is negative. Right, so you must know your graphs. You can see that. So xy is equal to k. If k is positive, then you have a curve in the first quadrant and third quadrant. Then if your k is negative, it will be second quadrant, fourth quadrant. Right. So in this case, x times y is equal to a positive number. So therefore our graph will be in the first quadrant and third quadrant. Okay, so the first quadrant here and the third quadrant. Now notice that in the third quadrant there is no point of intersection. Can you see that? So basically this is not required for this problem. We want the area bounded by these two curves, and here is the area bounded by the two curves. So it's bounded in between these 2 points of intersection. Can you see that? So that means we need to find that point of find those points of intersection. And now, let's find it. So to find points of intersection, simple, solve simultaneous equations. So let's take our equation. We got y is equal to 4 minus x, if I make y the subject of the formula then. Right, so now what I'm doing is I'm making y the subject of the formula 4 minus x. I'm going to take this equation, substitute into equation 2. Alright, so now x times y is equal to 3, so that's x times y equal to 3. So what is y? Y is 4 minus x, so there's my 4 minus x, and now I can multiply x times 4, that will be 4x, and then x times minus x, that will be minus x squared equals to 0. Okay. Sorry, equal to, I'll just take there, sorry, equal to 3. Alright, so I got mistake, x times y equals to 3, there's an x times y equals to 3. Now, we need to solve for x. So now, we have a quadratic. Let's make this equation equal to 0. So what I'm going to do, let me take everything to the right hand side. So therefore I want a 0 on the left. So therefore it's going to be x squared minus 4x plus 3. Right, so if I take it to the right, x squared minus 4x plus 3, now it's equal to 0. And now let's factorize. So the factors here are, well, you've got a minus and a plus, which will always be minus minus. Okay. We have a negative and a positive. When you factorize in a quadratic, it will always be a negative. Negative. Why? Because if you add two negatives, the result is a negative. If you multiply two negatives, you get a positive. That is factorization. So there's your 3, there's your 1. Negative 3 times negative 1 is positive 3. Negative 3 adding negative 1 gives you negative 4. So therefore, x is equal to 3 or x is equal to 1. And it's almost, you can say almost accurate there on the board. So there's your 3 here. When x is equal to 3 and here x is equal to 1. So now, what we need to do is find the corresponding y values. When x is equal to 3, what is y? So I know that y is equal to 4 minus x. You must test both equations. So let's do this one for now. When x is equal to 3, y is equal to 4 minus 3, which is 1. So that means when x is equal to 3, our corresponding y value there is 1. And then when x is equal to 1, y is equal to 4 minus 1, which is equal to 3. So there's my 3 here. Right, so those are the points of intersection. Let's label these graphs. Okay. So let's call this one, what is this? This is the straight line. Y is equal to 4 minus x. Can we call this y1 is equal to 4 minus x. The hyperbola xy is equal to 3. So I'll go y is equal to 3 over x. Let's call this y2, so that will be x2, this will be x1. Now just to make sure that these points of intersection are correct, you must test out the other equation. Just in case this is wrong. So let's test it out. we know that, xy is equal to 3, y is equal to 3 over x. Let's test out when x is equal to 3. So y is equal to 3 over 3, which is 1. When x is equal to 3, y is equal to 1, it satisfies both equations, not just one. Okay, so that is correct. Let's test out the other one. Y is equal to 3 over x. We are testing out when x is equal to now 1. So y is equal to 3 over 1, which is equal to 3. So you know that's correct. 1 and 3. Right, so we know that is correct. Now, we need to draw our representative rectangle. We need to make a choice. We will deal with it both ways here. Okay. Right, so it all depends now on your choice. So let's go with delta x here. Choosing this type of representative rectangle. Alright, so let's choose that type of representative rectangle. Right, so now the labeling, the diagram is the most important. Okay, the diagram must be 100%, otherwise everything goes wrong after that. So now we have clearly area bounded by these two curves. You can see there these 2 points of intersection. We decided to make a choice. We decided to use that type of representative rectangle where the longer side is the difference between the two y values. So if delta x is the change in x, then delta y is the change in y. We need to write down the length. We need to check what's touching the top of that rectangle, what's touching the bottom. That's all. So now, what's touching the top, I called it y1, and what's touching the bottom, y2. According to how let's call this one y1. If you want to, you can call that y2. This way doesn't really matter. Okay, but because I labeled this as y1, that means I cannot go and write down y2. That means I'm not making sense if I do it. Okay, now labeling the coordinates. Alright, the centroid of the representative rectangle. Okay, so what do? You know that whatever x value you're going to have, whatever x value that exists within this area, the midpoint or the center point here, the y or the midpoint here will be y1 plus y2 over 2. So that is how we label it. Okay. Now, if it was the other way around, it will be x1 plus x2 over 2. But we're going to deal with this. Now, so once that is sorted out, you are now ready to work out the area and the centroid. Okay, so that is the first one. Now, calculate the distance of the centroid of this area from the x-axis. Okay, so the distance from the x-axis. So you must understand that if you ask the distance from the x-axis, that means find the y coordinate or the y coordinate of the centroid. Right, so be careful. If it says distance from the y-axis, then you are finding x. Right, so now we know we are finding y. So what is the formula for y? Y is equal to mx all over a. So what does this mean? Moments about the A stands for area. So remember, if you're finding y, it will be mx. Area is area. Okay. If you're finding x, it will be my. So that's how you remember. Now let's find the area first. Alright, so delta A, area of the representative rectangle, we know it's length times breadth. So we know that area is length times breadth. So here is your rectangle. The top is, what did we label the top as? Y1, the bottom as Y2. Okay, so the length that's the length, and this here is the breadth of your representative rectangle. So the length is the difference between these two y values. From here to there, if I want the length, I'm going to subtract top minus bottom. Now clear with that? And that's going to be y1 minus y2 times your breadth is delta x. So that is, this is a compulsory step. You must write down the formula for the area of the representative rectangle. Now you will write down the total area formula. Total area, that's dA y1 minus y2, and there's my dx. So now it's a substitution part. So what is your B and A? Now remember, this is dx. That means we are integrating with respect to x. That means we are interested in the x value at the beginning and the x value at the end. So go to the beginning, the smaller x. There's the beginning of the area here. There's the end of the area. So the beginning, it starts at 1, ends at 3. Those are the x values. Okay, so now from 1 to 3. What is y1? Now go to your diagram. There is y1. What do we need to do? This is dx. That means we are integrating with respect to x. We need to get y1 in terms of x and then y2 in terms of x2. So y1 is 4 minus x minus y2. There's y2. y2 is 3 over x. And then the integration for this one is simple. Integrating 4 for x. Integrating x, that will be x squared over 2. Integrating minus 3 over x. Do not forget that this is the same as minus 3 times 1 over x. Okay. Minus 3 over x is the same as minus 3 times 1 over x. So you are actually only integrating 1 over x. That's what you are looking at. So it's minus 3 times ln absolute value of x. You don't have to write down plus c. So this is 3 and 1. Right. So now take out your calculator and let's see what we get. Alright, so substitute 3, we get 4.204163134. You got that? Can you substitute 3? Minus, when you substitute 1, you get 7 over 2. Do not go and do the whole thing one time. You won't know where's the mistake. You must know when you substitute 3, what is the result? When you substitute 1, what is the result? So if it's wrong, then you can always go back and change it. So that's minus 7 over 2. And I'm getting 0.704163,134 units squared. Did you get that? Right, do not round off. You do not round off to 3 decimal places here. This is not the final answer. Write down as many decimal places as possible. Okay, so there's no rounding off. We still need to work out the numerator, mx, moments about the x-axis, and then we will divide and get our answer. Alright, so now let's deal with mx. Alright, so now let's do the limits. So now delta mx, so the formula for moments is area times distance of the centroid from, now from which axis? If it's x, it will be from x-axis. If it's y, it will be from the y-axis. And so you cannot go wrong here. Right, so it's area times distance of the centroid from the x-axis. Okay. Now, what is the area? Here is the area. Here's the area. So the area is y1 minus y2 times delta x. Right. Then the distance of the centroid from the x-axis. So there's the x-axis. If you are measuring from the x-axis, you are going up or down. So if it's from the x-axis, we are measuring the y value. If it's from the y-axis, we are measuring the x value. Right, so remember that. From the x-axis will be y1 plus y2 all over 2. This is how you need to learn it. Don't rely on the formula sheet for this. All this whole chapter 5. You must know it the way I'm showing it to you. Right, so now simplify. What do you notice? y1 plus y2, y1 minus y2. Difference of 2 squares. Right. Just that you got half here, take out the half. So here's your half here. And then we have y1 squared minus y2 squared times delta x. Alright. And then we can now get total. So when I write down total moments, I'm just going to write down mx, and now I will integrate. So I'll put in my integration there, so that's my half. y1 squared minus y2 squared dx. Integrating with respect to x, same b and a value. Right, so this is how we get the formula. You must remember it this way. If you just rely on the formula sheet, then you're going to be taking a chance. You won't know which formula to use, you see? You must check your diagram. From the diagram, you derive the formula, and then it all works out fine. Right, so let's do the substitution. Substitute for y1 and y2, let's integrate. Okay, so where are we? We got the formula. y1 squared minus y2 squared, difference of 2 squares. And so now we need to substitute. So this is B and A, it's the same B and A for area. It's not going to change. So your A is 1, your B is 3, and then Y1. What is Y1? So Y1 is represented by 4 minus x. So here is my 4 minus x all squared, and then Y2. What is my Y2 here? It is 3 over x. So there's my 3 over x all squared. Now it's the integration part. Let me give you 2 minutes. Let's see what you can do with the integration and the substitution. This should be easy. Right, so now the integration part. Do we need to simplify anything first? That's always the first thing to check. Do we need to simplify anything first? Is everything in standard form? Okay. So clearly, this cannot be integrated. It's not in standard form. This, there's 2 ways to deal with this. You could remove the brackets if you were in N4. Right, so you can remove the brackets. But from N5 and now in N6, you know that you do not have to remove the bracket here. You can use integration by inspection. Okay. Or you can use U substitution, because this is the type. This here is the type f of x to the power n multiplied by f prime x dx, which is equal to k f of x to the power n plus 1 over n plus 1 plus c. So this satisfies this condition here. Almost the derivative of minus x is going to be minus 1. Okay, so by inspection. So let me just do that. So now I got this is equal to, there's the half there. So this half, I'm going to multiply it by my final answer. So I got 4 minus x all squared. Okay, so what am I going to do? By inspection, the derivative of minus x is minus 1. You clear with that? But there was no minus 1 there, so I'll multiply by minus 1 or divide by minus 1. See, it's the same thing. A negative times a negative is a positive. So what did I just do now? I wrote down my f prime x here. Can you see that? And then I cancelled it because by writing my k here also by my negative here. So basically it's back to its original state, which is just a positive. Right, that is integration by inspection. So now this is going to be minus 4 minus x. 2 plus 1 is going to be 3 over 3 in one step. That is integration by inspection. In N6 level, you don't have time to go and remove brackets. You're not going to finish the exam. You must be able to integrate one time. Right. Now here, this one. Okay, so I had my minus 1, 4 minus x. That's squared, that's minus 1. I'm just showing you the integration in one step. This is not simplified. So this is going to be 3 squared, which is 9, divided by x squared. But you need to take x to the top, which is going to be x to the power minus 2. So when you integrate it, it's going to be minus 9x minus 2 plus 1 is minus 1 over minus 1. Now I'm substituting 3 and 1. Right, with that advanced calculator. Right, so let's see what we get. Plus 9 over x. So when I substitute 3 getting 8/3. When I substitute 1, I get 0. Okay, so therefore 1/2 times 8/3, 8 divided by 2 is 4/3 units to the power 3. Because it's a moment, it's units to the power 3. Because you know it's going to be area. Area is unit squared. Distance is a unit. Unit squared times unit is units to the power 3. So that's my 4/3. Anyone got the 4/3? By doing it a different way. Not sure that you squared it out. It's up to you. So now we want y, which is equal to mx over a. What is my mx, which I just worked out now? 4/3 units to the power 3, and your area is units squared. What is the area that we worked out? I just wrote it down here now. 0.704 163,134. 0.704 163,134, and then we get 1,893,500,624 units squared divided by units. Sorry, units to the power 3 divided by units squared is just units. So now, rounding off to 3 decimal places, I'm getting 1,894. Is that the correct answer? Alright, so that was working out the y value. Alright, so we are restarting the example, not exactly the full thing. I don't need to show you how to work out the points of intersection. That's simultaneous equations. You can work that out. X-intercept of the straight line, y-intercept, that is not a problem. Right, so the focus is on what would happen if we use a horizontal representative rectangle. Right, so that is our rectangle. So if we use a horizontal representative rectangle, so this is what I'm doing. So this is what we have. We have delta y, which is the breadth. So if you're using delta y, call this x1, call that x2. We're dealing with our 2 points. So there's a jet. So let's go here. Let's call this part here x1, x2. So now we know the length. This is the length. The length is from here to here. So that is your length. And you know this is the breadth. And labeling the centroid number. So this is going to be x1 plus x2 over 2 and y. Right, so that's very important in the beginning. That's x1 plus x2 over 2 and y. Right, so we label it. Now, let's start working out the problem. So now what are we looking for? Calculate the distance of the centroid of this area from the x-axis. That means we're looking for y, right, which we already know. So we are looking for y. We know that y is equal to mx divided by a. Let's work out the area first. Okay. So area delta A is equal to length times breadth. area is equal to length times breadth. So if I want the length, it is the difference in the x values here. The length is from there to there, the longer side. So I'll subtract right minus left. So that's going to be x2 minus x1 times your breadth, which is delta y. So now total area, I'm going to integrate, that's d and c, x2 minus x1, and there's my dy. Right. So now, what's your d and c? Now we are interested in the y value at the beginning. That means the lowest point of the area. You go right to the bottom, and this is the lowest point, the point of intersection. Y is equal to 1 there, and the highest point here, y is equal to 3. So now that is 1, 3. What is x2? x2 is touching on the right. This x2 is touching here. So there's x2 here. What is x2? x2 is the straight line. Can you see that? x2 is the straight line. Right, so it's a straight line. We need to get x2 in terms of y. Right, so remember there you got y minus 4x. Sorry, what is it? Y minus 4 plus x is equal to 0. This is x2. Make x2 the subject of the formula. So x2 is going to equal to 4 minus y. Right. Minus x1. So remember that xy is equal to 3. So x1 is equal to 3 over y. So there's my 3 over y there, integrating with respect to y, and the integration now, the final part is simple here. So I integrate 4 with respect to y, that's just 4y. Integrate y, that will be y squared over 2. Integrate 3 over y, you know that's 3 times 1 over y, so that's 3 length absolute value of y. There's my 3, there's my 1. If you compare what we had before, it's just that it's not x now, it's y. Okay. You can go and double check everything on the calculator. What do we get? So we got if I substitute 3, I get 4.2. 0, 4, 1, 6, 3, 1, 3, 4 minus, substitute 1, 7 over 2, which is 0.7041631334 units squared. That's your area. There's no rounding off here. You do not round off this here. This is not the final answer. Okay. What we just worked out now is area. Now let's work out mx, moments about the x-axis. So we know the formula is area times distance from the x-axis. Distance of the centroid from the x-axis. Okay. How do we know that? Because it's mx, it will be distance from the x-axis. If it's my, distance from the y-axis. Right, so now, let's see. Substitutes. Right, so my area. Area, there's your area right here. So your area is x2 minus x1 times delta y. Distance from the x-axis. Okay. So if you are measuring from the x-axis, you are measuring a y value. If you're measuring from the y-axis, it's an x value. So from the x-axis, look at what you label here. From the x-axis will be y. Are you clear with that? From the x-axis will be y. So that's going to be y. That's the y value. If I say from the y-axis, it will be the x value. So be careful. You make sure that it's labeled properly. And there's the gel. This is the distance from the x-axis. This is the distance from the y-axis. Now, total. I'm going to integrate. That's going to be d and c x2 minus x1 times y dy. So now, my d and c, the same d and c, which is 3 and 1. So what is x2 in terms of y? We have everything here. There's x2 in terms of y, x1 in terms of y. So therefore I got 4 minus y minus 3 over y. But this time it's multiplied by y. Can you see that? And then I have my dy. So now, simplify. Remove the brackets here. 4 times y. That's going to be 4y minus y times y will be minus y squared. And minus 3 over y times y is going to be minus 3. So you simplify. Let's integrate now. This is going to be 4y squared over 2 minus y to the power 3 over 3 minus 3y. Substituting 3 and 1. Let's see what we get. Substitute 3 first. I get 0. Okay. Substitute 1. I get minus 4 over 3. So a minus times a minus will give me a positive 4 over 3 units to the power 3. So now, was this the same answer that we got before? Yes. Okay. So therefore, we got y is equal to mx over a 0.7041633134 divided by 4 over 3. Sorry, my mistake here. I just realized it now. I did it the other way around. Sorry, that's mx over a. So that's going to be 4 over 3 divided by 0.7041633134. Let's come to the same answer. 4 over 3 divided by 0.7041633134, and then we get our 1,894 units. Right, so that was dealing with it both ways, dealing with using delta y, using delta x. You should be able to apply it to the other examples.